Welcome to Time for Math, because it's time for some math. So before we get started, I was going to show you something that I found. Found this guy. He's on the street, just hanging out, and maybe someone left him outside, and maybe some child could have grabbed it, but I figured no parent would probably let their child just have something off the street. I got it for my cats, but they didn't like it as much, but I just thought he was a funny guy. It's got like a, it's kind of got like, it's like a little bit asymmetrical. But he's super happy. Bend his ears a little bit, kind of asymmetrical. But I was reading Where's He From, and he's an edible arrangements bear. So like when you get like fruit basket or something, then this bear comes with it. So he's retired now. He's gonna hang out here with us. He's been added to the best friendship list, so a very positive person. And yeah, my first best friend is my bed, because it's the most comfortable bed, and the color is like, it's gray, and the sheets are so soft, everything. So that's number one best friend. Number two best friend is my cat's tied, Mr. Zeke and Miss Evie. That's tied for second best friend. Number third best friend, just sharing with you, is my printer, and he is the most reliable guy. Right now, it's plugged in all the time. Right now, if I said, "Hey, could you print something?" he'd say, "Sure." It's coming right out. It's also a fax machine. It's also a scanner, and I've made some videos, some like animations, and I wouldn't have been able to do it without my printer. And sometimes it's like there's a screen, and you can read. It says things, and so when I print something off, I take it. He often says, "Please don't take the paper before I start printing." I didn't take the paper before I start printing, but he's like extra cautious. I think he likes to observe his creation after it's been printed. Anyway, so that's third best friend. Fourth best friend is the stuffed animals, and so that bear can now be added to those. A few other guys. So that was a nice find this week. What else this week? I just like practicing my drawing skills, making sure they're still there, so I drew this. Wanted to share that. It's a bird, and it's a bird contemplating its next nest. So, but I copied it from the cover of my sketchbook. So, okay, not bad though. And the other thing I wanted to draw for you is I've been wondering what's the shape of the universe, or what's the shape in my mind, and I finally figured it out, so I want to share it. Okay, so it goes like this. Okay. Can you see it? Okay. Okay, so it's like a torus or something that intersects itself, perhaps. But it's like you're born and then you die, or you give birth to something else. I don't know, but it's just been thinking about that for a while. Couldn't figure out how to draw, so there it is. Okay, so that's just a little bit about me and my week, but I'm feeling kind of a vibe here, learning some things. So let's do some more math. Last time we were talking about power set and using binary tree to represent a power set. And today I want to talk about binary numbers and binary strings. So last time we were really using binary strings, so I was looking at the definition of binary. There's two definitions. One's, I'll just look it up because it's so the first definition of binary, relating to, composed of, or involving two things. So when we do a binary strings for when we're doing power sets, that's like binary string. We could have used like hearts and stars or something, I guess. And number two, relating to or expressed in terms, expressed in a system of numerical notation that has 2 rather than 10 as its base. Okay, so that's what we're going to talk about today. Is binary, as in binary numbers. Okay. So first, let's take a number. A number that we're used to, 523, let's say. So this is base 10. I'll assume it's base 10 if I just saw this number. If I had that in my checking account, I'll assume it's base 10. So let's wait. What is base 10 again? So let's look at what these mean. So with base 10, we have each digit represents power of 10. So this is the ones position, and the tens, and the hundreds position. So we would interpret this as 3 ones, 2 tens, and 5 hundreds. So see that? So we would say really it's like 500 plus 20 plus 3. And those are powers of 10 because 1 is really 10 to the 0. 10 is 10 to the first, and 100 is 10 squared. So if we want to do this in base 2, we'll have the 1's position, the 2's position, the 4's position, the 8's position, powers of 2 instead of powers of 10. So let's make a new. Okay, so now we have the 1's position, which is really 2 to the 0. How many 1's do you have in your number that make up your number? 2 to the first, 2 squared, 2 to the third, 2 to the fourth. So now, just like with the number 10, with base 10, we have digits for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we just use those digits. We don't actually use 10. 1, 0 really means 1, 10, and 0, 1. So I guess what I'm just trying to say is that when we do base 2, we only use the numbers smaller than 2, so 0 and 1. Okay. So let's write a number. So what should we do? Should we count or should we just figure it out? Let's count. So let's start with 1. How would you represent 1? So 1 is just 1, right? Just one ones. Okay, 1 is the same base 2 or base 10. Okay, I'm gonna erase that up. So then what's 2? So 2 we'd need 1, 2, and 0 ones. Okay. So now this symbol 1, 0. This pair of symbols 1, 0 now can mean 2 for us instead of 10. Okay. So let's keep going. So that's 2. So 3. Let's see, 3. So we have to do everything in terms of 2. So if you think about the number 3, maybe you would want to write it out as writing it in powers of 2. So that's 2 plus 1. So we have 1, 2, and 1, 1. So that's 3. So 1, 1 is 3 in binary. 4. So 4 is a power of 2. So I just need one of those. And then 0, 2s, and 0, 1s. 5. So 5 is 1 plus 4. So I can just, this is 5. 6, what do you guys think? So 6 is 4 plus 2. So there's 6. 7 is 6 plus 1, you could think. And then 8 is a power of 2, so we'll just go to 8. So let's make another binary tree. Last time we were coding subsets, and I was just doing it I was doing it only according to a code that I made in the moment. So let's make another binary tree, but I'll try and do it in a more ordered way, and we can see the first 8 numbers on the binary tree. Okay, so I'm going to start with just the root, and then I'll go to the left, I'll say 0, to the right I'll say 1, and I'll follow that kind of pattern. So from this node I'll go 0, I'll do nothing really. I could say 0, 0 maybe, but I'm just going to move like that. And then from this node 1 I'll go 1, 0, and 1, 1. And then we'll do one more level here. So again, 0, and 1. Okay, and from this node, okay, so this is really the number 1. Okay, so I'm going to add a 0. Okay, that makes it 2. Add a 1, makes that the number 3. Okay, and then from this one, I'll go to the left and I'll just add a 0. And I'll go to the right and I'll add a 1. This one, same thing, I'll go to the left and add a 0. And go to the right and add a 1. Okay, so now we've got another binary tree, but it has different interpretation. So I can see all the numbers now, the first 8 numbers. So each path is going to represent a number. The label that I give it at the end will be the number for this path. Okay. So this is 0, the number 0. Here's the number 1. Here's the number 2 in binary. Here's 3, 1, 1. Here's 4, 1, 0, 0. Here's 5, 1, 0, 1. 6, 1, 1, 0. And 7, 1, 1, 1. And then we can go up another level to get the 4-digit numbers, including 8. Up to what? 16. Probably. Okay, so that's all. And so, maybe where am I going to go with this eventually? Well, if we kept making this tree, or even the other tree I was making, it can be binary. You can leave it as binary strings or actual binary numbers. But if I kept going forever and made this tree infinite, maybe we'll talk about this next time, then each path in the tree represents a subset of natural numbers. Or you could think of it as a real number, and we can think of the real numbers as the power set of the natural numbers. And all of the real numbers can be coded as a path in the infinite binary tree. Okay, so that's enough for today, and hope you have a great day, and see you next time on It's Time for Math.